Hello guys, today we're doing LeetCode question 7, reverse integer. This is a medium question. Question is, given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range of minus 2 to the power of 31 or 2 to the power of 31 minus 1, then we return 0. Assume the environment does not allow you to score 64-bit integers signed or on site. So example 1, x is 1, 2, 3, so the reverse integer will be 3, 2, 1. X is minus 1, 2, 3, so the reverse integer will be minus 3, 2, 1. So the minus stays the same, the negative of the number stays the same, but just the digits are reversed. And x is 1, 20, so the output will be 2, 1, 21, because 0 at the start will be 0, 2, 1, so the number is still 21. And the way we do this is by, I'll show you in whiteboard first. Okay, let's say we have a number of x of minus 1, 2, 3. The first thing we do is set a variable to check whether it's positive by checking if it's bigger than or equal to 0. This is not bigger than or equal to 0, so it's positive equal to it's false. So we lose a negative number. Then what we do is create another variable which is a number. We can change it to x, but we'll have number here as a placeholder. And we set x to a string. So now x is equal to 1, 2, 3. Oh no, first thing we do is we set it to a whole number. So Math.absolute it. And then we set it to a string. So x is now 1, 2, 3 as a string. As with Math.absolute, we're saying it's a whole number, that negative, the minus is removed. Then we split them, so now number is equal to an array of strings of 1. Let's go back. Array of strings of 1, 2, 3. Then we use a built-in reverse function. So now the number is an array of 3, 2, and 1. And then we join it. So it's now a string. Let's make it smaller. So now number is a string of just 3, 2, 1, 3, 2, 1. Now we check. If positive is true, we pass integer of number. Also positive and false, we pass integer of negative number, so minus negative number. This way we return the reverse number, and this way we reverse the number and then turn it to negative. So it will still be the reverse number that is negative. Let me show you how to do this in code. Oh, and also we have to check if it's out of the bounds of 2 to the power of 31, so 2 to the power of 31, or negative 2 to the power of 31. So let me try to do this in code. So the first thing we do is we check that the value is positive. So we save a variable as is positive, and we set it to x. It's bigger than or equal to 0. Bigger than or equal to 0. So if it is, it returns true, else it returns false. Next, we set x to x.toString. So this turns to a string, then we split it at each character. Then we reverse it, and then we join it at each character, at each string, sorry. Okay, this reverses the numbers and turns it into a string. Then we check if positive is true. Sorry, so if is positive is true, then x is just passing integer x. Else, if it's negative, we have to pass it as a negative value. So we set x to negative integer of x. And then we have to check if it's out of bounds, and we return 0. So if x is bigger than math.absolute, sorry, math.power. I forgot to change this to math.absolute here. So math.absolute x. So this pretty much sets the negative to a whole number positive, and if it's positive it stays the same. Then here we check if the power of 2 to the power of 31 So if it's bigger than that, minus 2, so if x is smaller than minus 2 to the power of 31, or 31, or x is bigger than math to the power, so 2 to the power of 31 minus 1, then we return 0, else we return x. Now let's check if that passes. It does. Let's submit. As you can see, this is the fastest time complexity, one of them, which reaches 99% of people, and also one of the fastest space complexities, as we're only storing a single variable checking if it's positive of 0, 1. So you can see it beats 99% of people for runtime and 99% of people memory. The space complexity of this is of, I believe, O n. I just have to reverse it, which pretty much checks for each string, which is O n. And the time complexity, again, time complexity is O n, and space complexity is O 1, as we're storing a single variable, which never changes. Thanks for watching.